we're going to give this a second run. So this is a recording, a re-recording of a video made in class from 220. So we're going to give it a little bit more of a polished look since it was the audio quality was really hard to hear. All right. So this morning we were looking at a function that was 4 minus x, and we had restricted the domain between 0 and 4. And as we were looking at the geometry of this figure, we could see that it was a right triangle. And so we knew that we could figure out the exact area of this triangle by notifying that we have the height of 4 and a base of 4. So half the product of 4 and 4, which is 16 divided by 2, or 8. And so that was the exact value. And then we looked at situations when we had a lower sum and an upper sum. And we looked at the left endpoint, the midpoint, and the right endpoint for those three situations. And so I want to take a moment just to kind of create a a visual for what we're doing here, and then extend that visual to what we're calculating um, with respect to the values here. So if I hop over here real quick. So if I sketch the graph here and I look at the situation here, maybe a little bit bigger, but so this is y equals 4 minus x. And so the left endpoint looks at the height of the rectangles where the left coordinate or the left corner of the rectangle determines the height. And so each of these values for this particular function, as we discussed on Monday, corresponds then to the height of the rectangle. And so we're going to need to make as many rectangles as we choose to approximate the area. And so you can see that each of these shaded areas here are a little bit more than, or a little bit of an overestimation. Okay. And each of these locations are the locations of the x values that we need to determine the height of the rectangle. So we have the height here. It's given to us as 4 minus x, and so we want to utilize our the geometry here and recognize, since the bases are the same length, then the delta x is going to be b minus a over n, where n is the number of rectangles, b is the right endpoint, and a is the left endpoint of over. We're using 4 as the number of rectangles, and so that means that our delta x in this one is a pretty large base. It's a base of 1, but it's to illustrate this point. Okay. All right. So for the left endpoint, the one that we just looked at here, the left endpoint, what we have is a xi that's equal to, and assuming our sum is always going to start at 1, we're going to have a plus I minus 1 delta x, where in this case, again, delta x is equal to 1. A is equal to 0, and our I here is going to start at 1, but we're subtracting 1 from it. So that actually gives us then the left endpoint, which is the height that we're looking for. Okay. Our right endpoint, the right endpoint, if I draw this picture, okay, so the right endpoint then is going to correspond to where each of these rectangles, the heights are corresponding to when the right side of the rectangle, okay, that determines the height. And so um, each of, not that one, but this one, and this one, and this one, and this one, and this one will determine the corresponding height. But you can see that there's this little bit of shaded region here now, and that's the reason why this one was an underestimate of the total area for um, and the right endpoint then is going to be xi, and that's going to be again a plus. And since this is counting in step with our counting, so that's going to be I times delta x, where delta x again is equal to 1 in our case. Okay, and then the midpoint is the average, if you will, of these two. It's the midpoint of these two, and so it's the sum of this and this divided by 2. So if I have, it's going to xi is going to equal a, plus um, a minus or I minus 1 delta x plus uh, delta xi divided by 2. Notice that delta x is common in both, so I can factor that out. And then I'm left with 2i minus 1. So this simplifies to a plus I over 2, 2i over 2 minus 1, which we can write again as a equals, or a plus I minus 1 half. Okay. So, so that would be then the midpoint, that uh, relationship that would give us the sort of like the average, if you will. So it's this one minus this one. So the midpoint, um, the heights of the midpoints, again following that same situation, would correspond to rectangles that look like, um, assuming they were all the same length, but uh, my drawing is a little off, but you can see it's what I'm trying to do is get the midpoint of each of the rectangles. That's what's determining the height. And so you get a little bit of an overestimate here, but a little bit of an underestimate there. And so you can kind of see that those areas almost cancel out exactly. And so as we saw, that the midpoint is probably the most productively or most accurate, sorry, I should say most accurate calculation for the area under the curve here. Okay, so then remember that the Riemann integral is defined by the relationship that you have the limit as n goes to infinity of the sum of call it I from 1 to n. And so this 1 here is what's defining each of the terms here for the different i's. And so we have f of xi delta x, which is creating the second term there. This is the idea then. This I here is what controls the counters for each of the different midpoint or each of the different heights for the rectangle. Okay. All right. So in our case, we're not going to worry about taking the limit as it goes to infinity. Or we're just going to look at the finite sum of 1 to 4. Okay. And so for each of these, what we're doing is we're estimating, we're making approximation that this is going to go from 1 to 4 of f of xi delta x. And again, delta x for this situation is equal to 1. Okay. And depending on whether we choose left, right, or midpoint, the f of xi will change its values. So for the left endpoint, or abbreviated LE, what we're going to have is f of 0 times 1, that's a delta x, plus f of the next xi would be at 1 times 1. Again, the 1 is the delta x, just to kind of be clear. And then we have f of 2, and then times 1, and then f of 3 times 1. And that would be the 1, 2, 3, 4 rectangles that give us the area. Again, this is the base and this is the height. And so these are the areas that we're looking at. I'll do it down here. The right end point is going to give us then again the same equals 1 to 4 of f of xi delta x. And so here f of our first one is going to be according to our relationship here, a is 0, I is 1, and delta x is 1. So our first value there is going to be at f of 1, 1 plus f of 2 times 1 plus f of 3 times 1 plus f of 4 times 1. And it shouldn't be a surprise that f of 4 happens to be, of course, up here, if you look at the graph, or actually right here, this is f of 4, and it's going to be at 0. So that actually doesn't contribute to the height at all, which is the total area. And then the midpoint, this one is going to have some fractions in it, but that's okay. They're at least reasonably nice fractions. So this is going to be f of 1 half times 1 plus f of 3 halves times 1 plus f of 5 halves times 1 plus f of 7 halves times 1. Okay. And so those are going to be the values then for uh, our function for each of those values. And when we jump back into GeoGebra, what we're going to be doing is we're going to be looking at each of these and calculating what they are, or at least having the computer calculate those results. So hopefully that adds a little bit of clarity to both the sums and also how we're computing them. Okay, so let's jump back to GeoGebra then and see what this looks like using the technology. Okay, so here then this is going to be our location for each of the xi's. So I'm going to put this in my delta x and quote like that so it doesn't get evaluated is equal to 1 for each of these. And so I can just grab this and pull it down. I'm going to do 4. Okay. And then let's see, our left endpoint, call it LE for left endpoint. Okay, what is that equal to? So it's going to equal, um, let me go back up here and plug in A equals 0, B equals 4. So we have those values in there. And then I have, this is just A. This is A plus, actually, maybe I'll do that to the left. So this is the counter I for, we don't need it, but there we go. Okay, so then the left endpoint, of course, would be, I'm gonna pull this out too, just to kind of give us a little bit more room to play. Okay, so the left endpoint would be A plus delta X, which is A2 times I, which is B2. Okay, there. And now we're just being a little bit more formal. So now I can pull this down, and that should give me each of the values then that correspond to our values here for our heights. Okay, and then the midpoint, we'll come back to. Let me do the right endpoint. Again, I'm just using the RE as a simplification for right endpoint. Okay, so this is going to equal A plus, you know what, I made a mistake back here. And no one was here to correct me. Okay, so let me redo this one. This one is A plus I minus 1. So this would be A2 minus 1 times the delta X, not A2, sorry, B2 minus 1, because this is the I, times delta X, which is the A1. No, not A1, A2, silly. A2, there we go. That's the left endpoint that we need. And then if I pull this down, of course, it gives us then the other 3 points. Okay. And then over here, the right endpoint is going to equal A plus our delta X, which is A2 times I, which is B2. And this, of course, then is the correct formulation for the XIs. And then here, the midpoint is the A plus I, which is B2 minus a half times delta X, which is A2. Okay, so that gives us then, so those are our 4 XI values, the left here. Okay, and the reason I'm doing this now, let's go ahead and do that. Yeah. This is going to equal, for the left endpoint, is going to equal 2 times A2. Okay, and this is going to equal, so then, and then this is going to equal F of, let's see, E2, that's this cell, times A2. Okay, and then the right endpoint area, I guess I should label these P. This is area RE. Okay, and this is going to be equal to F of, what is it, G2 times delta X, which is A2. Okay. All right, so let me see if I can get all 3 of these, and then I can just drag them down. No, it looks like I can only do it one at a time. So, okay, so there's the individual areas for each of them. And now to figure out the total area, what I'm going to do is highlight all of these, and I'm going to sum. Okay, I'm going to take all of these, and I'm going to sum. I'm going to take all of these, and I'm going to sum. And so you can see here, I get 10 for the left hand point, I get 8 for the midpoint, and I get 6 for the right hand point for the areas. And so we have here, of course, that this is the upper sum, the lower sum, and then the actual value in this case is right on with our predicted value from the formula for the area. Okay. All right. So I hope this is helpful and where the i's come from, and then also how to compute the function, right? So the area again was right, left, or midpoint, depending on what scheme you're time. And I will see you in